You are welcome back to the second video of on D operator. So in this video we'll be explaining the theorems that we will apply in this D operator to make what the work and the make simplification of this differentiation and integration very easy for us. So stay tuned as I take you through. Now the first theorem is what this called what theorem 1. So for theorem 1 we have function of what d, you already have your d, and is differentiating what an exponential function. Now whenever you have what an exponential function, so it's same as what the exponential function of what the coefficient of what the power of x in that what exponential. So since I have what e to the power of what ax here, then I simply bring it as what the differentiation of this as e to the power of what this x, then the function of what f of a. So I simply write this. So in this case, d is replaced by what? Just this coefficient of what of the coefficient of what the power of what the exponential, so which is this, right? Now for a good example is that, so if I have d of e to the power of what ax, so the differentiation is simple. It's just to have what my a will come and multiply what this exponential, right? Just come and multiply this. So if I have what d to the power of 2, then it means I will simply remove my d and replace it with what a, then I have what 2. So if I have d to the power of 3, so it's to remove d and just replace it with a, then I have what 3. If it's 4, then it's the same thing, a to the power of what 4. Here your a is a constant or real or even what a complex number. Alright, now let's take some examples so that at least you will understand it better. Now the first example is that we have d squared plus d multiply what an exponential what function, right? So the first thing to make it easier is just to simply what open the bracket, right? So I open this is multiplying this, which will give me this, then this is multiply this, which will give me this, right? Now using what theorem 1, since I have what e to the power of what ax, is simply to just replace my d with my a here, right? If here was 3, then it means I just simply replace my d with 3. If here was 10, then I simply replace my d with 10. So for this differentiation, it means I simply have what my a square, then multiply what the function. Plus this one is just d to the power of 1, then I'll remove my d, just replace it with what a. Then same for this e to the power of what as is common, so I can bring it out, which will then give me what a square plus a in bracket. So I have another question here. I have what d square minus 5 is different. It's multiplying what a function e to the power of what 2x. Now looking at this is a function, is a constant, right? So which was replacing a. So it means, okay, so the first thing I open the bracket, this is multiplying this, so I have this, and then this multiply this, which will give me this. Then the simple way is just to remove my d and replace it with what this coefficient of x, which is 2. So I have 2 to the power of what 2, then multiply what this function. But here there's no d, so I simply what open the bracket. So for this 2 to the power of 2, something is common, e to the power of what 2x is good common. They have what 2 square, which will give me 4 minus 5. Then 4 minus 5 will give me minus 1. Then I have this function to be what minus 1. And don't forget, the way we explain how to solve this in our previous video, you can still solve it like that. You see that you get the same value, but with this theorem it has made the work easier. You just simply remove what, bring it down your coefficient, replace it with what d. Then let's do for this. We have 2 d square plus 5d minus 2. Then this, open this bracket to give me this, 5 this, open this bracket to give me this, then minus 2 d. Now the coefficient of x is 3, right? So it means I simply have 2 multiply by, I remove d, replace it with 3, so which will give me 3 square. Alright, then I have this function plus I have 5 here, multiply by d, I simply remove this d and replace it with 3. So I have the, but here there's no this, so it still what remain the same. So from here I have what 3 square will give me 9. 9 times 2 will give me 18. Then I have this function. Plus then 5 times 3 will give me 15. Then I have this exponential. Then this, open this bracket. I will have this, right? So this is common, right? So we have what 18 plus 15 minus 2, which will give me this. So if I sum everything here, I will have what 31 e to the power of what 3. You see, just simply applying what the first the theory one make the work simplified, right? So instead of trying to differentiate and be thinking what to have, you just simply what apply what theory one. And even when you decide to see differentiate them, you still have what this constant. You can try it and tell me your answer in the comment section if your answer is different from the answer we get here. Now let's solve another question. We have 1 all over d square minus 40 minus 1. Now looking at this, normally if we tend to use our normal d operator, this may be difficult for us because of this. Then with this, that theorem 1 have what simplified the work for us. We have e to the power of what minus 2x. So it means we simply replace our d with minus 2, right? It's simple. We replace our d with minus 2, right? So from here we come, which is same as this. So my d, I will replace it with minus 2, so I have minus 2 square minus 4. My d, I will replace it with minus 2, so I have minus 2. Then I have minus what 1. So minus 2 square will give me 4, right? Yes, will give me 4. Then here I have minus 4 times minus 2 will give me minus 8, right? Will give me minus 8. Then I have what minus 1. Then if I sum everything up, will give me what 11, right? Because this will give me, okay, let's say, yes, minus 8. Yes, minus 8 here. Okay, sorry, plus 8. I have what 4 times times minus will give me plus. So I have 4 times 2 will give me 8. Then this one will give me 4. So I have 12. 12 minus 1 will give me 11. So I have 1 all over 11. So this function, after differentiating or applying what theorem 1, it gave me what this. So this also 1 all over this. But don't forget, whenever you have inverse, it was supposed to be what integration, right? But for this we have 1 all over then differentiation, right? But normally if you decide, okay, if you open this for this one to come up, it will now be this all over this, right? Which we supposed to then integrate. But using our what simple theorem 1, yeah, it has simplified the work for us. So we don't need to come and say we want to be integrating it or differentiating. Just simply what apply what your theorem 1, it will make what the work easier for you. For this I have what e to the power of what 3x. So it means that my a is now 3. So wherever I see d, I remove d and put what 3. So for this I have what 3 square plus 6 multiplied by 3, then minus 2. Then if I simplify, this will give me 9. 9, this will give me 18. 9 plus 18 will give me 9 plus 18, then minus 2 will give me 25, right? Then multiply by this, I have this. Then also try to simplify the following. So here your a is 5 here, just to replace d with 5. So I have 5 square minus 3 open bracket 5, then minus 2. Then you simplify it. Then for this one, I have my a is what minus 3 here. So here it means I should have what minus 3 square, which will give me 9, then plus 4, then this here. So I can decide to what apply the same thing. My a here is what minus 1. You also put minus 1 here, minus 1 here. So it's all what the same thing. And don't forget, try to apply theorem 1, and also you can use the first method we used in our first video. Then you can do the comparison. If the answers are not the same, then you can comment on the section, comment your answer so that we can also verify. Now we have theorem 2. For theorem number 2 is that we having an exponential function, then we having another function that depends, or yes, another function of x, right? Just like that other product function that we saw when we told you we have x squared, then we have what, an exponential. This one is just like that because this your v is a function of x, right? So whenever you have a function like this, because here you normally supposed to apply what, a product rule. So to make it easier, what you simply do is, for this you now have function of what, d plus a, right? You have d plus a. That is what you do. You replace your d with what, d plus a in this function, where a is what, a constant, real or complex, and v is what, a function of x, right? Because this v here is what, a function of x. Now let's take some examples to make it what, easy. Then here I have what, e to the power of what, ax, then a function of x. Don't forget, for theorem 1 and theorem 2 is when you are having what, an exponential function. For exponential function, you have to note it. Okay, now let's continue. We have d squared minus d plus 5, then this, and don't forget, for this v must be what, a function of what, x. And we said whenever you have anything like that, replace your d with d plus a. So it means, for this, it means I should be having d plus a, then square, plus, for this I will have d plus a, right? For this there is no d, so there is nothing to replace there. So this will now be what, the function, right? So this I will have what, d plus a, then square it, then minus d that we have what, d plus a, just like that. There we have this. Now let's take an example where our v is a truly function of what, x. Now this was the one of the assignment we gave, that we say we should what, solve. Now we have exponential function and we have another function multiply, which is also supposed to give us a product rule, but this function is what, is a function of x, right? So what you simply do, we said, wherever you see d, replace d plus a, and it's simple. Now what is our a? Our a is 3 here. So in place of d, just simply remove d and put d plus a. A is 3. Then you see I have what, your plus 4. Then I have what, my function outside, just like the way we explain here. You see the function is still outside. So I have this. So I have d plus 3 plus my 4 that is here, then I have what, the function of what, x, which is this. So opening this bracket, I have 3 plus 4, which will give me 7. So I have d plus 7. Then I will open this bracket, right? I will open this bracket. Here I will be having d s squared plus 7 s squared. So normally I've already applied what, my theorem number 2. Then for this, having this d is still here, so to remove this d is simply what, I do what, my normal what, differentiation. So I'll differentiate this to give me 2x. So I have plus 7 what, s squared. Then this will multiply this. So I simply what, open the bracket, and we have what, this, or I rearrange it to have what, this. Now let's take another example. I have 1 all over d squared minus 8d plus 16. I have e to the power of 4x is multiply what, s squared. So it's still simple. I have what, an exponential, it multiply what, a function of x. So it means wherever I see d, I will remove d and put what, d plus a. So here I have d square, I will remove it and put what, d plus a square, minus, I have minus 8, I will remove d and put what, d plus a, d plus a. My a is 4, don't forget my a is 4. Then here I have what, plus 16. Then the function is still what, outside. Then the next thing is for me to open this bracket. I will open this bracket and what, add everything that is inside. So if I open this, don't forget this will give me d square plus 8d, right? Yes, plus 8d, yes, plus 16. Yes, this will give me d square plus 8d plus 16, right? Then here I have what, minus 8d, minus 8d AD is gone. Then here I have 16. I have 16 here. Yes, I have 16 here. But here I'm supposed to have plus 16, right? Supposed to have plus 16. So yes, I supposed to have plus 16. So normally 16 plus 16, so it's supposed to give me what, like 32. It means maybe, yeah, I see there's an error here. It's supposed to be what, minus 16. Yeah, it's supposed to be minus 16. So I have what, 16 minus 16, which will then disappear. Then I will have what, this square. Sorry, please correct this what, minus 16. Let me quickly correct it before we continue. Here supposed to be, let's say, minus 16. Yes, here should be minus 16, because if it's plus, it's supposed to give me what, 32. So it's minus. It's minus. Let's just allow it to save so that we can continue. Sorry for that error. I did not see it before the class. I just now I noticed it. So I will here I will have 1 all over what, this square remaining, right? 1 all over this square, right? 1 all over this square. Then I normally I should have x square all over what, this square, which is what, second order what, differentiation. Second order differentiation. I will differentiate this in first order. It will give me s cube divided by 3, right? We have what, s cube divided by 3. Then I will integrate it again. So the second order integration, I will integrate it again to now give me x4 all over. I will have all over 3 then multiply by 4, which will then give me what, 12. So I will have what, this all over what, 12. Now I have another question here. I have d square plus 2d minus 3. Then here I have what, e to the power of 2x sine x. Then from here, now I have exponential, then I have a function of x also. So the simple way to solve it is just to replace my d with what, d plus a. So I have d plus a square plus 2. Here d will now be replaced with what, d plus a, and a is 2. So then I have what, minus 3, then sine x. Then opening this bracket, I will have d square plus 4d plus 4, right? Then here I have 2d, then here I have 4, then minus 3. Then if I sum everything up here, it will give me d square plus 6d plus 5. Then I have what, sine x, right? I have sine x. Here, as don't forget, I've already applied the second theorem. So here I will have to what, use this to multiply what, each term of this, right? Which means for the first one, it means I have to differentiate this in second order, then 6d differentiate this in first order, and 5 sine x, right? So if I differentiate this in second order, sine x, right? If I differentiate sine x, it will give me cos x, right? It will give me cos x, cos s. Then I will differentiate cos s again. It will give me minus sine x. Okay, I will have minus sine x. Then I will differentiate sine s. It will give me 6 cos s, right? Then plus 5 sine x. Don't forget I have minus sine x, then plus 5 sine x will then give me 4 sine x. Then I have what, 6 cos s. So I have what, this function. So we have another what, problem to solve. You can try your hands on this, and don't forget this what it cos s. So because you are having cos s, then it means you have to put what, replace your d with what, d plus a, right? Replace it with d plus a. So we are going to end this video here. It seems this place is little bit dark. So try to watch our next video, because we are trying to simplify everything to the best level that we can. try to watch the next video for continuation of this video. Bye and have a nice day.